cookie crumbles.
Plan on being out late.
You have Sunday. It's not like it's the day after prom. It's not like you go to prom and then you have to come take the test. You have a day to recuperate.
Yeah, but that.
Yeah, then I'm gonna try to recuperate and study for precalculus, which is just gonna that
Yeah, I work
cancels
8
each
hours
other
on
out.
Sunday, so that's yeah.
No matter when I give a test, kids, people are gonna complain. So I just don't care,
So I just
really.
don't get that.
Or just
See, Margot thought it was fun.
yeah, probably you shouldn't teach a subject that has test accountability because that doesn't really work so well anymore. When your school gets graded on your scores, and you get graded on your scores. So.
Next year, you have to change teach something for this. Yeah.
I don't even want to write it down.
No, I don't care. This is when we did stuff like x equals cosine t, y equals cosine t. Parametric equations are when you have three variables. You have two equations, one x equals, one y equals, and you have a t thrown in there. Which means really this is all you got to know from parametric equations. Be able to graph using an x, y, t chart. So you pick t values, and you plug them in to get your x's and your y's, and we graph like sideways parabolas, and we graph circles.
That points would we use for the T?
Just numbers.
Just like random.
Just if this look, that should say sine. Sorry. I mean, I guess it could be cosine and cosine, but that's not going to be a circle. If this was what you would pick for t, you'd pick angles. But we also did ones that are just numbers. We did just lines. Like there's one on your review today. It's just a line. It's just a slope-intercept form of a line, which is kind of silly to use a parametric curve for. But for sideways parabolas and for circles, it kind of makes it easier to graph than writing it in standard form. The other thing that you need to know how to do is eliminate the parameter. The directions are going to say eliminate the parameter, and you have to know that that means get rid of t. So you want to make an equation like, I don't know, x squared equals y plus 1, or y squared equals x minus 1, right? Like you solve it so that there's no t left. And what you're supposed to be able to do, what you're doing on your review today, is when you do that, based on what you get, you can tell me the shape of the graph without actually having to graph it. Or if I made you graph it on the test, that would be like a little test to see if you did it right.
Is that a circle?
This is not a circle. A circle is when both x and y are both squared, right? So with only one thing squared, it's a parabola. I tricked you. It's not a sideways parabola because if x is squared, it's a parabola that opens up or down. If y was squared, it would open side to side, and we have that in our notes. You could always just actually graph it to see. But that's pretty much the shapes. Sideways parabolas, circles, lines. Those are the only ones we really dealt with. And that's 6-3. Then we got into polar coordinates. 6-4 and 6-5 are both with polar stuff, but we started with polar coordinates, and then we got into polar equations. This is where you have to know the conversions here. So you're going to have to graph some polar coordinates, which means you need to make sure you remember how to deal with that negative r like I was just talking about. If I asked you to graph -3 pi halves, you have to know that you go up to pi halves and you add pi or you flip it over. So you really would graph that down at 3 pi halves. So you're going to have some points to graph. But then the rest of 6-4 was all about converting points like r theta to xy, or the other way around. You just put the arrow going this way too. Or if I gave you the xy point, you could change it to r and theta. That's where you have to know those equations. X equals r cosine theta, y equals r sine of theta, x squared plus y squared equals r squared. If you notice, these are the exact same equations that we've been using in 6-6, except for instead of x and y, we use a and b. It's the same thing, only in complex numbers, we talk about a and b instead of x and y. So to convert from here to here, all you do is plug r and theta in there, and you get your values. Sometimes it will be ugly, and you'll have to use your calculator and get a decimal, and sometimes it'll be something from our unit circle, which means you can actually give me an exact answer with radicals. And then converting equations, you use the same stuff for converting equations. You just have to substitute in for your x's and your y's or your thetas and your r's. Definitely we'll look at some of those as we go over the review tomorrow. There's definitely some tricks to it. That homework quiz that I passed back to you yesterday, the one at the bottom that was a circle that you had to foil out, and you had to put, substitute in for all those. Like, that's definitely one that you're going to want to look at. But sometimes it's just as easy as, like, this would be a really easy one. If I said x squared plus y squared equals 4, what kind of graph does that make me? X squared plus y squared equals 4. A circle, if I wanted to convert this to polar form, well, look at this equation. X squared plus y squared equals r squared, which means you could just say that that means r squared equals 4. And remember that we like to solve for r, so we could say in this one, r equals 2 would be the polar form of that form. Vague memories of doing that? Maybe not. And then in the next section is 6.5, and that's what you guys did that rose curve activity over when I wasn't here and I messed up and forgot a page. But hopefully, at least you got the idea of the shape out of those. And so that's 6.5. Can I go to the next one?
Yes. So, do you say when you remember all the equations that was trying?
We're about to talk about it, because the only thing that I'm going to give you on the test is from 6.5. 6.5 is the graph of the polar equations. You need to be able to look at the equation and know the graph, because that helps so much when picking your points. I'm going to give you all the limaçons. I'm actually just take the page out of the book that has the 4 pictures, and they give you the ratio from A to B, because that's how you tell the difference between a limaçon with an inner loop, a cardioid, the convex one, dimpled one. It's all about if A over B is less than 1 or A over B is equal to 1. I'm going to give you those. You don't have to know those, but you do need to know how to recognize rose curves, circles, and then the other one were those lemniscates. It's like the most obscure vocabulary of any math chapter ever. In this chapter. Well, though, it's just knowing that, though. If I say name the graph, what kind of graph would this make? You need to know. I mean, that's knowing the vocab. And so you'll just want to go through those, and we'll go through those tomorrow as we go over the review. But the rose curves, that's when there's a number in front of theta, like 2 theta or 3 theta. The circles don't have a number in front of theta. And the lemniscates, remember, that's the only one that has a squared in it, and so it's easy to remember that one. But you just need to know those. You're not going to have to graph much. You're just going to have to recognize them, and that's what you'll see in your review today. And if I ask you, if I give you an equation for a graph and I say how many petals does this rose curve have, or what's the length of the petal, then we should be able to do that from our equations also.
Isn't it? If it's odd, it's just that.
Yeah. So like if I had r equals 2 cosine 3 theta, how many petals does that have? 3, and what's the length of the petal? 2. And just like the one on your worksheet that we just turned in, you're supposed to be able to use that to help you if you had to graph it, because you don't have to pick a million points anymore, because you can say, oh, I know that's a rose curve with 3 petals, and I know the length is 2.
So how do you distinguish if it's cosine?
It's all about where it's symmetric. If it's cosine, then it should be symmetric on the x-axis, and if it's sine, it's symmetric on the y-axis. But even if you forget that, if you picked a couple points and you found like where the length of that petal starts, then you'll kind of know how to make your graph from there. There's going to be a couple graphs. Oh, I just stepped on the cord. That sounded like something just broke. Sketch the graphs. They're going to be simple graphs, and they're going to be the basic shapes. Remember the ones that we did on the graphing calculator that I showed you, like some cool like rose curve and a rose curve, and we described them as like animal shapes? That's not going to be on the test, because that was just kind of a little further application of it. You're only going to have to sketch basic ones that hopefully knowing those equations will help. Okay, so not a huge part. 6.6 is what we've been working on most of this week, and there's a lot of stuff from 6.6, a lot of formulas. And Angel, that's what we were talking about, but I'm not going to give you these formulas. Oh, look, I think this is the stepping on that I just did because it's not working now.
This one of the plugs that was in the back of your computer.
That's right, we'll just do this. And I'll find the plug while you write this.
Here, that light's on.
It's like by the wall.
By the wall.
It's like right next to the wall, and it's like fallen down by the box.
This?
No. Go towards the wall.
Where's the wall?
No.
It's right here.
Oh,
You're a genius. Thanks. All's as well.
Maybe, don't break something else.
Really need some cord help in my room.
How about you just put them on the wall, like this?
There's too many.
Or something, just put them.
I didn't do all this mess. There's just too many to fix. I need to just stand over here is what we always decide, but I can't help myself. I like to stand on that side. My microphone's over there.
Get duct tape, push.
That's right. It's exciting when I step on it. Excitement happens. There are questions on your test that you just have to graph these numbers on the real imaginary axis, which sounds crazy to someone that's not been in our class, but that's actually pretty easy, right? That if I gave you the point like 2 minus 4i, that we just graph that as here's the real axis, here's the imaginary axis, and we go 2 on the real axis, down 4 on the imaginary axis. How about that for a test question? Everything that we've done in 6-6 since that first day has been converting from standard to trig form or trig to standard form. So I hope if you've been catching up on your homework, if you've stayed caught up on your homework, that you're able to do that. That's going from a plus bi to the r cosine theta plus I sine of theta, where you just have to use, again, the same things we used before, that a equals r cosine theta, b equals r sine of theta, and a squared plus b squared equals r squared. And if you can convert that, then you can do the other things too. It's just a little bit of formulas to remind ourselves of. 6-6 day 2, we talked about multiplying and dividing in trig form. Remember that when you multiply the r's, you add the thetas. When you divide the r's, and you subtract the thetas. That's an easy one. It's probably the easiest formula that we have. Just reminding ourselves of that. And then de Moivre's theorem, that's what we did on the homework quiz that you took yesterday. I'm going to get those graded and handed back to you tomorrow so that you'll have something else graded to look over before the test. But de Moivre's theorem, what we just did on the worksheet, expanding to a power, like to the 7th power or the 10th power, using de Moivre's theorem. And then finding those nth roots. And remember, there's a pattern there. So if you see one on your test that I say find the 5th roots of this complex number, remember, I'm not really expecting that you do all the computations for all 5. You can, but there's a pattern every time that you can recognize and work those out. No. I want you to be able to, like, you don't want to do all the work. So you get extra credit points for doing it faster than that, okay? I am going to break this test up into 2 days, just because it's one of those borderline tests. It took me like 16 minutes to do the test, and I know that sounds ridiculous, but I usually take how much it takes me and multiply by 3. 16 times 3, that's kind of borderline to do in one period. So we will take half the test on Monday, and then we'll just take the other half on Tuesday. And it's not broken up one way or the other, it's just me tearing the test into 2 pages. Okay? So that way you won't have to worry about time. I don't want you to do bad on the test because you didn't have enough time.
Is that like you go like speed demon, or are you just normal pace?
I'm a pretty fast test taker, so it's my own little formula that I come up with. When I taught Algebra 1, like honestly on the Algebra 1 test, I would multiply how long it took me by like 5 or 6 because, I mean, you know, I'm old. I've been doing math a really long time. And so I know how to do it. And so I always multiply, in Algebra 2 I multiply by 4 because I can do Algebra 2 pretty fast. But here I only multiply by 3 because I still have to do the same work you do. Like I still have to find r, I still have to find theta. But why can I do it so much faster? 1, I've been doing it a long time. And 2, I know what to do on the problems. You know, like it's my job to know what to do. So I don't get stuck and say, what was the nth roots again? Like when I read the problem, 1, I wrote the test. But, you know, like it's not a surprise to me to say, what do I need to do? So that's why I do that little formula and multiply, just to try to make it a reasonable test. So I usually like to get done in about 13 minutes or less. Like to me, if it takes me about 13 minutes to do one of your tests, then I feel like it's a good test that will take most of the period, but it's doable. Not every person, I'm a fast test taker. I was one of those kids that loved those time tests, you know. Remember in like 2nd grade, we had 2nd grade times tests, and the person that got like all the 100 multiplication questions right first won a New Kids on the Block watch, and I won a hot pink New Kids on the Block watch in 2nd grade. And I was so excited, and then I got in the shower with it on, and it was not waterproof. It's my sad story about doing too fast, test too fast. But I'm a pretty fast test taker, you know. I don't know. You should hope your math teacher's gonna do your tests pretty fast, right?
Yeah.
You don't have to write this stuff down, but just some notes about the test. We aren't going to use graphing calculators because we're not going to do the really advanced graphs. We're just going to do basic graphs. I will give you the descriptions of the Limathon graphs, like we said before. And the graphing that you have to do, it's going to be pretty simple. So I don't want to give you the graphing calculator because I want to see that you can graph it. And homework will be due Monday. I will grade it and get it back to you. But the review is due tomorrow because I'm spending an extra day reviewing, not just so we can just sit in here and sort of do our work, but because I want to go over the review tomorrow. So tomorrow, first thing, I'm going to come around and check your review, and then we're going to go over it, whether we go over every problem or just the problems that you have questions on. We're going to spend tomorrow not working on individual problems that we haven't done, but going over the questions that we have. So that way, when you leave here tomorrow, you should know what I need to study for this test. If you have no questions tomorrow or every question you have gets answered correctly, you don't have much to study. But if you come in tomorrow and you don't understand any of the review, then you'll know you have a lot more to study. And for those of you, I know some people are doing prom decorating tomorrow. I will record going over the review tomorrow so that you'll have access to that. And I'll even write myself a note so I won't forget to upload it before I say, did you have a question? You got an answer? Okay. It is a little short in time today because of bright time, but we are in here until, what, 2:20. So you have a good amount of time that you can get started on this. Notice there's lots of odd problems. That's not because I just want you to copy all your answers out of the back of the book, but I want you checking your answers so that when you come in tomorrow, you'll know which ones you have questions on. I did this one, that's not what the back of the book says. I did this one, I have no idea how they got this. And the ones that you do get right in the back of the book, you won't necessarily need to check those or have me do those on the board tomorrow. Questions in general